So this is the HCI routing and switching entry lab guide, the lab guide. So make sure you've opened it. This is what you'll be following in order to do the labs. So you can see, for example, at the entry level, so these are some of the icons, just to mention some of the icons that represent the different network equipment that you're going to be using. For example, a router, a switch. We're not going to use a firewall. We might meet a cloud somewhere. Straight line for an Ethernet link. A thunder-like icon there for a serial link. So those are some of the icons that you should be familiar with. So the very first lab is lab 1.1, building basic IP networks. So that's what we're gonna do in the next 30 minutes. Then the next lab is basic device navigation and configuration. So that one we're gonna do it after learning about VRP. But for today, we're doing lab 1.1, building basic IP networks. So let's scroll to page 1. So in each lab, the lab will have a title. It will also have the learning objectives. So for example here, the learning objectives are to set up and navigate the eNSP simulator application, to establish a simple peer-to-peer network in eNSP, and lastly, to perform capture of packets using Wireshark within eNSP. So you should always read, at least read the title so that you can understand, then read the objectives so that at the end of the lab, you can come and ask yourself, have I really been able to set up a peer-to-peer network in eNSP? Have I been able to capture packets using Wireshark in eNSP? Then the other important thing that you'll always get is the, here they didn't put it, is the topology. And other than the topology, you'll also have a scenario. So they'll simply give you a scenario. Then after the scenario, you'll now have tasks, the different tasks that you're supposed to confirm divided in steps. So for example, sometimes I'll be asking you, in which step are you? Ni step gani umekwama, namna hiyo, namna hiyo. So most of these things we've already done, like installing eNSP, blah, blah, blah. We've already done most of these things. And now we just want to begin so that I take you around. So for lab 1.1, I'm not really going to follow the lab guide. I'm just going to take you around it so that you know how to use eNSP and you get familiar with the different parts of it. So are you able to see my eNSP?
Yes.
And have you also opened yours? Najua saa zingine hii window inakuwa full, especially nikishare my screen, but you can always double click it, but it's not necessary now. You can double click it so that you can resize it if you also want to access your eNSP. But in the meantime, I think I'm also recording so that if you need to reference anything, you can be able to see that much later. Okay. So let's begin. So this is called eNSP. eNSP is a network simulator, network simulation software, a network simulation software. It is quite advanced. Just like in Cisco we have the packet tracer. We have another open source network simulator called, I think, GNS3 or something. So a network simulation software is a very powerful software because there's nothing you can do in a real network that you can't do in the simulator. So some of the things you can do in a simulator is to design the network, to plan the physical topology, the logical topology. You can be able to configure switches, routers, and in fact, you can be able to copy those configuration files from your network simulator and simply put them in your real router or real switch, and they'll be able to work. So a network simulator is a very powerful tool that you should know how to use. And for all the labs that we're going to do, we are going to be using the Huawei network simulator called eNSP. Now, eNSP is very simple. I really like its interface. It's very simple. So we have a top menu there. Then we have two other parts here. So we have a part here, and we have another part here. It's very easy. And of course, at the bottom there, we have another row there. Okay, so let's begin with the top menu here, this top bar. So the first icon there is used to create a new topo. So just like we call Word documents a document, we call Excel sheets a workbook or something, here every file you create is called a topo. I think it's a short form of topology, a network topology, a topo. Then you can also create what you call a paper project with that icon. You can open previous topos by clicking on the open icon there. You can save as, you can print your topo, you can undo, you can redo. You can click on the arrow icon to move things around and highlight things, hand icon to move things around, this X icon to delete, this one to delete all the lines. Lines are simply links. If you've interconnected routers or end devices wrongly on wrong interfaces, you don't need to delete one by one. You can simply click on delete all lines. Then this one is used for labeling. I'm going to show you that in a short while. This one is used for marking different areas. Sometimes your topology might have different areas, and you want to distinguish them with different background colors and different shapes. You can always use the drawing palette for that. Zoom in, zoom out. Zoom in, zoom out from your topo. Then this one to reset the zoom to the default 1:1. Then this one to start a device, to put it on. This one to shut it down. This one to do data capture. We're going to do data capture right now. This one to show interfaces, the labels for interfaces, whether you want to show or hide. This one, if you want to have a grid as the background of your topology. We're going to try it out. This one for command line. Then here we also have the settings and the help. Settings and the help. So let's just begin by creating a new topo. So you create a new topo by clicking here. So please do that. So you can just minimize this window, then click on the new topo icon. Are you there?
Not.
Yes. So I want us to move together. So make sure you are on it. Okay. So have you been able to click that? So new topo, when you open new topo, you should see this white area here. Now, if I click on this show grid icon, you see what showing grid means? I like it plain. I don't like the grid. So I'll just click on it on that again. Now, in this area here, you have all the devices that you might want to use within your topology. So router icon, switch icon, wireless access points, firewalls, So if I click on that, at the bottom here, I get a list of routers. So we have different versions of routers. So I click on switches, the list changes. We have S5700, S3700, etc. That one for wireless access points, for firewall, for end devices. End devices can be PCs, servers, cell phones, and other clients like a web client. Then the cloud, for example, frame relay switches, and also the cloud itself. Then this one is for the media. So when you click the thunder icon here, it gives us the different types of media. The most common one that we're going to be using is copper and serial. Copper and serial. So here, I want you to click on this monitor icon. Have you done that? So you can just unmute your mic so that if you have an issue, you just say it. You can stop us as quick as possible. So once you click on that, I want us to drag two PCs. You can click and drag, or you can simply click on it. You see, I click on that, then I click on the PC. When I click on that, I can be able to drop 1, 2, 3, as much as I want. If I want to have back my cursor into an arrow, I go to the top bar here, then I click on the arrow. Once I click on the arrow, now my cursor is back to an arrow, and now I can drag things around. I can highlight things and so on and so forth. So for example, I can simply delete this PC by clicking on it. Then I just want you to drag two PCs, but if you've dragged 3 like me, you can delete one of them. So I choose to delete PC2 here, then I click on delete here on the top bar. So are you sure you want delete? Yes, like that. Now I want this to be named PC2. So how do I do that? I simply double click on this label. So you see, if I double click, tack tack, it opens that, and I can press backspace, and or I can even rename it completely, maybe to host B. And then this guy, I rename also this guy. So you simply double click to host A. So it's important that you know how to rename devices, because in order for us to be able to help you to troubleshoot your network, your topology must be exactly as it is on the lab guide. So always make sure that you label your devices in a similar manner. So in case you've dragged in 2 routers or 3 routers and you only needed 2 and the names are differing, simply double click on that label. It should open up, then you give it a new name. So after that, I want you to click on the thunder icon here on the left here. You click on the thunder icon, and I want us to interconnect these 2 devices using copper. So click on copper. So when you click on copper, when you hover into your topo, you see it changes into an RJ45 like icon. So click on host A. You have to click on it. Then it's going to display a list of interfaces that it has. In this case, host A only has 1 interface. An interface is just a port. The name of that interface is Ethernet. Then 0/0/1. So this is the name. This is the number of that particular interface. I'm going to tell you more about that shortly. Then drag your icon to host B, click on it. Then again, it only has 1 interface. Then to get back my arrow, I click on the arrow icon on the top, like that. So I just need to mention this, that on interfaces, especially Ethernet interfaces, we have the Ethernet interface and we have the gigabit Ethernet. So gigabit Ethernet can do up to 1 gigabit per second. Yes, Cynthia?
Okay, I'm not able to drag the the serial whatever.
Actually, you're not clicking on the serial, you're clicking on the copper cable. So you click on the thunder icon here, then you click on the copper cable. These devices do not have a serial interface. So you need to click on this, then copper. Then you click over host A, it should display. So have you been able to do it?
Okay, let me try it.
Yeah, just do it. Just do it. It should work. Click on copper, don't click on serial. So these are the two Ethernet cables that you're going to meet, or interfaces that you're going to meet in these labs. Always make sure you choose the correct one. If the topology says gigabit Ethernet, don't use Ethernet interfaces. Use gigabit Ethernet. Okay. So now, the next thing you need to do is to organize your work a little bit so that it looks good. So how to do that? Look, I click here and drag. I click and drag. I drag over host A and host B. Then I right click over host A or over host B. Then I click on horizontal align. Horizontal align. So you have to right click. If I right click anywhere else, you see you get a different list of options. But if you right click over the device, you get horizontal and vertical align. But when you right click anywhere else, you get a totally different menu. So while we are on it, we can also now drag these labels so that they are just below this dot here. It's red because we've not started the devices. In case you're not able to see the label for your interface, you need to go to this top bar and you toggle by clicking on this icon. So two people have raised their hands. Please go ahead. I can't really see your name.
Hello, Mr. Kevin.
Yes.
For me, I think I'll prefer or I'll request that maybe we see the way you are doing it, and then maybe you give us a chance, because every time I move to my eNSP,
unapata nimesonga sana.
Napata umesonga sana, so I'm missing some points here and there.
I think that is okay because I can still share with you this video alafu mfanye. I think that's a good suggestion. Okay, so just watch. Just watch.
Yes.
That would be the best thing to do for now. Okay, so you can click on this show interfaces if you are unable to see it. If you are unable to see the labels. So my advice is that all the time, make sure that you are able to see the label. The reason being, inakusaidia uweze kujua ya kuwa you are configuring the correct interface. So it will help you during the configuration. So always make sure that those labels are visible. Then you can...
Excuse?
Yes, go ahead.
Yes, where are we clicking so that we can see the interfaces?
Here, on the top menu. Sijui kama...
Oh, yeah. I see.
So, you see?
Okay, thanks.
Good. Okay, so I can right click over host A, then I click start to start that particular device. When it starts, it changes into a lighter color. I don't know what color that is. Then I can also right click on that. So you can start them one by one. You can also highlight like that, and then click anywhere within the area, stop them or start them together. If your machine is low on RAM, don't start too many devices at the same time, because it's going to crash your eNSP, because it's going to request for too much memory which you do not have. So it's always advisable that you simply right click on a device and you click on start. So start them just one by one most of the time, especially routers and switches. They are quite heavy compared to these two devices here. Okay, so once we've done that, the next thing we need to do is to label our topology. So for that, we use the text icon here on the top bar. So in particular, you need to label the network. So for example, this one, we want it to be 192.168 192.168.1.0/24. So that's our network ID. That's our network ID. And here we want to configure this interface on host A with .1. So I can just click that and drag it. I can also click and drag that one a little bit. I can zoom in. Can zoom into my topology like that. I can zoom out. Right now I want to zoom in a little bit so that you people can see it more clearly. And again, I can click on the text icon, and I want to configure this interface with the IP address .2. So if your mic is on mute, make sure you are in a quiet place or you just mute it. So let's now configure these IP addresses. So we configure an IP address in host A. How do we do that? You right click, then you click on settings. You right click on host A, then you click on settings. So a number of things we can be able to change here. Yes, some people have raised their hands. Please go ahead. Anyone with an issue?
Mine is a question.
Yes, please.
Regards the color code when adding text.
Okay, thank you for that. I can. So the default color is, I think, green or something, but I changed mine to yellow. It's just a matter of preference because when I'm teaching and I'm using a projector, I think it's more visible according to me, black and yellow with a yellow background. So to change how these labels look like, you can go here to settings, then you can come to, I think, font. So the font tab, then you have the CLI font and the text tip font. So hapa ndio nimechange size, background color na foreground color. So foreground color black. So you can simply click on that and then choose a different color if you want to. Change also the background color if you want to, and also the size. So mine, I've just made it a little bit bigger for that purpose. Similarly, you can also change the one for the command line interface. I'm going to talk about that when we configure the router, I think in our next lab. Okay, so again, to configure this IP address, we right click on host A and then settings. So under settings, we can just give it a host name now. The other one was just a label. So under the host name field here, you can just give it that. Then I want us to change this MAC address so that the last two values there ends with AA, so that you can always see that this MAC address is for host A. Then here you see, you can either assign an IP address manually. When you assign manually, sometimes it's also referred to as static. When you are assigning using a server, it's called DHCP. So here we are assigning manually. So we want to give this the IP address 192.168.1. So 192.168.1.1. The mask is /24, so 255.255.0. The gateway, you see, so if we wanted to communicate to devices on other networks, we would have configured the IP address of the gateway. In this case, we don't need to. And the other one is the DNS, domain name server, used to create an association between a public IP address and the domain name. For example, facebook.com is associated with a certain public IP address. So when your Facebook packets are going to the internet, they go with that public IP address and not with the name. So it is the domain name server or system server that is used to do that mapping and translation. In this case, we don't need to access any website on the internet, so we don't need to configure a DNS server. But we also have publicly offered DNS servers like this one for Google, 8.8.8, which you can use. But in this case, we really don't need it. So that is IPv4 configuration. IPv4 configuration. In this example, we are not using IPv6. So we only configure IPv4. So we've configured that. We've also given it a host name, and we've also changed the MAC address to end with an AA. The last thing you need to do is to click on this apply so that whatever configurations you've done will actually take effect. So just click on apply, then you close that window. Then you can do the same for host B. So you open up settings by right clicking on it, then you give it the name host B. You come here, you change the MAC address to BB, then you give it an IP address 192.168.1.2, 255.255.255. We don't need the rest. So after that, you click apply. Then you close. Yes, someone raised up their hand. Okay, so I'll proceed. So now host A and host B have an address 192.168. We can just confirm. You can also double click on it to open the configuration window. So so this is 1.1. Okay, subnet mask is also correct. You can also double click on that. This has 1.2, correct. So everything is okay. Okay. So Chris, you have a question?
Yes, kindly clarify about the DNS also, and also the public DNS.
What exactly?
The purpose of the DNS in the input, and also where do we apply the public DNS?
Okay. So the DNS server. So for example, in MMU, we have a DNS server. The purpose of this server is to translate domain names, e.g. facebook.com to an IP address. In this case, it's a public into a public IP address. So sikumbuki vizuri IP address ya Facebook, but if we do a trasat right now, we can get it, or even a ping. So kazi ya DNS server ni kitambo, before domain names ikue, if you wanted to access a server, you needed to know its address. But people are good at remembering terms compared to remembering numbers. So that's why they came up with the domain name. Then the server can now do the mapping between the number and the name. So in MMU, students will type in their laptop facebook.com. So that request will be taken to the server. Hey, who's facebook.com? Then the DNS server will reply with that particular address that is associated to facebook.com. So what I'm saying is, on the internet, we have, if you can allow me to call it, we have open servers that have been set up by companies like Google. For example, one of them is 8.8.8. So this is an open DNS server. So anyone can use it. within their network, and it will still translate. So that's the main purpose of a DNS. So is that clear, Chris?
Yeah, asante sana.
Okay. Hi. So now the next thing we have to do is I want us to do a data capture. I want us to do a data capture. And I want us to do a data capture. Oh, sorry. I want us to do a data capture here on this interface. So you come to this. You see this turned from red to green because now we have started the device. So the interface is up. So you can just right click on it, then click on Start Data Capture. So when you click Start Data Capture, it should open up Wireshark. So you see now the color changes from green to blue. So let me just share my entire screen, so that I think you can be able to see. Okay, so you're able now to see my Wireshark.
Excuse.
Yes.
Can you pardon like the previous slide? I want to get the Wireshark.
Or how to do data capture,
Yes.
So you see on this hata unaweza tu right click hapa kwa machine, then
Yes.
ukama hapa kwa capture data.
Yes.
Then you click on that interface where you want to capture data. So
Yes.
mi nilikuwa nime capture, so sahii imeacha ku capture. So
Okay.
if I want to capture, I right click either on the device ama hata kwa hiyo ka interface kenyewe hako ka dot, then you click on Start Data Capture.
Okay, thank you.
So once you do that, if your Wireshark is working, it should actually open. It should open Wireshark, Sawa sawa. So are you able to see my Wireshark?
Yes.
Okay, so Wireshark has several fields here that are important. For example, number. So number is just the sequence of packets as they come in. Number 1, number 2, number 3. Time when they came in, where they came in from. So source IP address, destination IP address. That particular packet or frame, which protocol is it related to? Then the length. Length is like the size of that packet, and any further information, more information about that packet. So that is what really we want to see here. So I'm just gonna press window, logo, and my left arrow. Oh, I cannot resize. Oh, no, wait. Okay, so I've just done that so that I can place my Wireshark on the left. Then I place my eNSP on the right. So am I able to do that? Let me see. Okay, let me just resize it. Can I resize it beyond that point? Just a moment, I'm trying out something. But you're able to see my eNSP?
Yes.
It's like I cannot be able to squeeze it beyond that. Anyway, I'll just pull my Wireshark then a little bit, or I'll put it up. Okay, so haina shida, I think it's okay. So now what I want us to do is to generate some packet from host A to host B using the ping command. So how to do that? We open the settings on host A, then we go to command. So the first tab there is basic config. The second tab is command. So under command, I want us to do a ping. So as we do the ping, we want to see how Wireshark will capture those packets. Okay, so I think good. So are you able to see this black window here?
Yes.
My command prompt, eh?
Yeah.
Yes.
Okay, wonderful. Okay, so here I'm gonna type ping, then I type the IP address of host B. So 192.168.1.2. Sorry, oh, what did I do? Let me just type it again. So ping 192.168.1.2, like that. Eh? So when I press enter, I want you to check this area here in Wireshark. So just check what is happening here. Okay, so I'm gonna come back here and press enter. Enter. Okay, so have you been able to see that?
Yes.
Yes.
Okay, so let me just explain. Let me explain first this part. So we've done a ping. We've done a ping, and we can see that we sent out 5 packets and received 5 replies. So we've had 0 packet loss. We can also see the round trip times, the minimum, maximum, and the average. But these are the particular messages. So we can see that we are getting replies. We sent a ping to this guy. We are getting replies from that guy. The size of this ICMP packets, 32 bytes. That was our first message, second message up to the 5th. TTL value 128, and the time. And the time. You can see, for example, here, it took less than 1 millisecond. That's why here, the minimum amount of time it took for us to get a reply was actually 0 milliseconds. So less than 1. So these times will differ depending on how much RAM your device has offered to eNSP. Okay, so from there we can now go to Wireshark and also look at what we have there. So I'll just blow up that window. In Wireshark, you can. There's actually no need to do this, but you can just drop that a little bit if you need more space here. So let's evaluate each of these packets. Now here it's really interesting because we're going to see everything that we've learned in theory. Now we're going to see it live here. So what is happening here is, as these requests are being sent and as we are getting replies, Wireshark will capture every packet that will pass through that particular interface. So that is what we're looking into. So let's look at the very first packet. Let's look at the very first packet here, this one. So you can see that this packet is coming from host A. Now look at the destination, it's a broadcast. Okay, look at the protocol that is concerned, it is ARP. Now you remember, in the command prompt, we only sent 5 packets and received 5 packets. But here, we're having 12 packets. Why? Because the first 2 packets, the very first 2 packets are actually ARP packets, an ARP request and an ARP reply. So you can see. So what is host A asking? Who has 192.168.1.2? Tell 192.168.1.1. So let's look at that. Let's look at that packet. Let's look at that ARP packet. So if I click on that packet, I can come on this lower section here, and we can start with the Ethernet 2 header. So you can just click on this arrow here so that we look at the Ethernet 2 header. So look, what's the destination address for that frame? broadcast, all Fs. What is the source MAC address? The MAC address of host A. Then look at the type field of the Ethernet 2 header. Which protocol are we passing this packet to? We're going to pass it to the ARP protocol. Then the padding field, it will be filled with all zeros so that it can have the minimum size of that particular Ethernet 2 header. Okay, let's go ahead and now move into the ARP header. So if we open the ARP header, we're going to see this. What is the hardware type? You see, it's an Ethernet. What is the protocol type? IPv4. What is the size of the hardware? 6 bytes. What is the size of the protocol address? 4 bytes or 32 bits. You remember the operation code? In this case, it's a what? It's a request. Look at the sender MAC address and the sender IP address for host A. Look at the target IP address. So that's how we're able to say this. Who has 192.168.1.2? Because we have the target IP address like that. The target MAC address here is supposed to be all zeros. I really don't know why eNSP puts it as all Fs, but in theory, it is supposed to be all zeros and not all Fs, because that is what we want to learn. We don't have it. So let's look now at the second packet here. So this should be the reply. So if I click on that, notice how things change here. At the Ethernet 2 header, now the destination is MAC address of A. The source B, because now it's coming from B. Let's look at the ARP header. Let's begin from the operation code. So the operation code is 2, which is a reply. Look at the sender MAC address, the MAC address of B, and the IP address of B. Look at the target MAC address of A, and IP address of A. So that is what we must do. That's the first thing we must do. We must learn the MAC address of B before we are able to ping it. So the very first packets we are going to do is we are going to do ARP. And of course, host A, the first thing it did was to check its ARP cache table. Haikupata MAC address ya B. Therefore, it generated a broadcast ARP packet. Please don't forget that an ARP request is a broadcast with all Fs. Okay, so now let's look at the ICMP header. So we click on packet number 3 there. So when you click on packet number 3, we can see the Ethernet 2 header here, the destination and the source. So we are sending this frame to B because we already have it, and it's coming from A. Then let's look at the Internet Protocol header, the IPv4 header. Okay, so you remember the version field has a value of 4. You remember the header length. So that IPv4 header, how big is it? 20 bytes. You remember the DS field, differentiated service field. Here it is 0 because it does not have any priority. The total length field, you remember it. The identification field for fragmentation, the flags field. So the flags field here, we are saying don't fragment because the packet is too small, so we are not fragmenting. And that's why the fragment offset field here is 0. Then you remember the time to live, 128 here. We saw it in the we saw it in the command prompt. So actually ICMP uses the TTL value of the IP header. Remember here we are in the IP header. Internet Protocol header. Then the next protocol to which we are going to hand over this packet, ICMP, you see? ICMP, that's the next protocol. Header checksum used for validation, integrity, source address, and destination address. So that is it. That is it about the IP header. So now let's look at the ICMP header. So I'll just click again on this arrow to hide the contents of those two headers, and I'll click on this so that we can see the ICMP header. So you remember the type and code fields. So in this case, it's type 8 code 0, which is a ping request. A ping request type 8. Checksum header used for validation. So checksum is good, is correct. Then the sequence number. Sequence number, you can see it is 1 here. So that is the ICMP header. So what if we click on the next, packet here? It should now change from a request to a reply. Okay, let me just close that. Okay, good. So you see the ICMP header. So if I click on packet number 4 here, you can see it's coming from host B, which has .2. It's going to the destination .1. It's an ICMP packet. So you see on the type, it is type 0 code 0, which is a reply. So the others are going to be just the same thing. Eh? Now let's do this. Let's come back to host A here and check the cache table. ARP -A. Are you seeing that? So the entry that had been put in the ARP cache table of host A has already been deleted. Now let me do another ping. So if I do another ping, the packet should begin from, Wireshark will capture the packet from 13 going forward. So we can look at packet number 13. So I'm doing another ping, it's successful. Wireshark is capturing. So let's go to packet number 13. So what's packet number 13? An ARP request. It's a broadcast, so it's a request. Now, let me shift back again to host A. Let me do ARP -A to see the cache table. So what do you realize? Oh, what did I just do? Sorry. Okay. So you can see, if we do ARP -A, we can actually see the entry. We can actually see the entry for that particular computer. And now, if I do another, so let's check here. So we are at packet number 24. So if we check packet number 25, after doing a ping, so I want to do a ping. So do a ping to computer B. So check packet number 25. Packet number 25. So it's an ICMP. So this time, unlike here, when we did the second ping, it did a broadcast. It did an ARP. Why? Because ilikuwa imedelete hiyo entry kwa cache table yake. But from here, we've done another ping and we've not done another ARP request. Why? Because host A checked its ARP cache table na ikapata hiyo entry kwa hapo. So it will just go ahead and use that particular data to send the ICMP packet. So that is it, ladies and gentlemen. I hope you've enjoyed and you've learned a lot. Wireshark is a powerful tool that you can always use to study the different packets and protocols that we are going to learn in this particular course. So that is how you do data capture, and that is how you analyze the packets of a particular protocol. Thank you very much for your time and your patience. I think that is it for tonight.